So what is the domain of this function? What is the domain of this function? So how far left does it go? It should be 12 or 13. It's 12 or 13. So how far to the left does it go? Does this arrow tell you? It keeps going. So what do we call that? Fantastic. All right, now how far to the right does it go? Huh? No, that's right. Fantastic. Okay, now how far to the right does it go? Not 6, but like in between 4 and 6. What number is in between 4 and 6? 5. Okay. And we're going to put a bracket around this one. The reason why we put a bracket is because it's inclusive. It actually touches it. Now, how does this compare to the parent function? Do you remember what the parent function of this one is? What does it look like? Or what's the equation of the parent function for this? The 12 or 13. Okay, so what does a parent function look like for a square root? The parent function is y equals the square root of x, right? Okay, when we draw that graph's going to look like this. You got boom, and then it goes over, right? So how does that compare to the domain of this parent function? So what's the domain of this parent function? Tell me what the domain is of this pink function. How far to the left does it go? What's the x value farthest to the left? What's the x value of this dot right here? 0. Great. How far to the right does it go? Infinity. Okay, so how are these similar or different? How are these similar or different? They both deal with infinity, and then they both have okay, so a bracket and then the parentheses. Okay. All right, so today we're going to talk about interpreting the domain. Okay, definitely want to pay attention on this one because this word problem comes up. You see it again, okay? And it takes a little bit of thought in order to get through this. I know it's Monday morning. Okay, so water is draining from a tank connected to 2 pipes. The speed f in feet per second at which the water drains through the first pipe can be modeled like this, where x is the depth of water in the tank. Okay, so really quick. Depth of water is going to be my x value. My y value is the speed that it drains. Okay, I would highly suggest that when you read these word problems, you go ahead and tell me what the x is and what the y is. They always state it in the problem. Before we even start doing anything, we want to look at what is our y value, and then what is our x value. And it tells you in the word problem. You just have to read. Now, let's think about this. What is the domain of this function? What are the x values of this function? So look at your graph. How far to the left does it go? Okay, well, if this is 20, that means that this middle line is 10, right? Which means that this line is 5. This line is 15. So what is this in between 5 going to be? It's halfway between 5. It's going to be some type of decimal, right? What is it? Not 3.5. 2.5. Okay. And then how far to the right does it go? Okay, let me back up really quick. So look at our equation really quick. Okay, we're not really sure what this number, we're not really sure what this number is because they don't tell us specifically what the number is. Normally, if they're going to give you a sketch of the graph, they'll tell you the exact number. But since this is a little questionable, we're going to look at our problem. What is the number right here? -2. And we know that with the horizontal shifts, it's always going to be the opposite sign. So 2 is going to be our farthest left x value. Now, let me ask you this question. Is it going to continue on to positive infinity? Why? So let's think about this in the context of the problem, right? Water is draining from a tank. Can we go look at our x values? We've got depth of water. Can it go on to infinity? No, like at some point it stops being certain depths, right? So it goes on until, look at what this number is. Okay, so it goes on until 64.
Also from the graph, you don't see the arrow at the end of that graph. So that means it's not going forever.
Okay, so what does this mean in context? Okay, that means, what does it mean according to this word problem? Okay, so from the left, we went 2 to 64. So what does the domain represent again? What does the domain represent? I'm pointing to it. If you look at the board, I'm pointing to it. What does it mean? Is the depth of water. So it only goes, it starts with, the tank starts with 64. We're dealing with gallons. It doesn't tell us what it's measured in. And goes down to 2 feet of water. They're emptying it, just draining. So Justin's physics textbook states that the speed s in meters per second of sound in dry air is related to air temperature T in degrees Celsius by the function s equals 20 times the square root of T plus 273. Identify the transformations as compared to s equals the square root of T. Okay, so from here to here, how are these different? It's got that plus 273. So what is that going to do to my function? Is it going to move it left or right? So it's going to move it left 273. And then what about this 20 out front? What does that do? Okay, so let me ask you this. We did this last week where we said, okay, so the number out front either stretches or shrinks it, right? And we learned this last week. So what is this number going to do? Okay, so a stretch of 20, right? And then left 273. Okay, so now what we're going to do is we're going to state the domain and the range in this context. Okay, so first I'm going to graph this one. Okay, so I'm gonna graph this one really quick. Now, when you graph this, you have to put an X instead of that T, okay? Unfortunately, Desmos does not read any other variable other than X, okay? Now, I don't see the graph. Well, that's because I have to zoom out in order to see it. What is my farthest left X value? What is it? What's my farthest left X value? Not 0, negative 273. Okay, now this keeps going on forever and ever, right? Okay, we're gonna come back to that in just a second. What about my range? What's my lowest Y value? I said it earlier. What's my lowest Y value? 0. And then it keeps going on forever and ever, right? Let's go back to our word problem because we want to determine this in context. There we go. And back to my word problem. Remember, it says that S is in meters per second, and it's related to air temperature. Okay, so we have negative 273 degrees Celsius. How hot can it get? We can look it up. Okay, so the hottest temperature ever recorded in Celsius is 56.7. So it can only go up to 56.7 potentially. Okay, my range, however, that's going to be dependent on my X values. So my range can only go up depending on what my X value is. So my highest X or my farthest to the right X value is 56.7. But now what I'm going to do is I'm going to go back into my graph and I'm going to look in the table and look at when 56.7 is my X, what's my Y? Well, my Y is 363.15. Now, obviously, you're not going to have one as complicated as that. You won't have to look up information. However, this is how you would do that. Okay, so a manufacturer wants to predict the consumer interest in a new smartphone. The company uses the function P of D is equal to -2, the square root of -D plus 20 to model the number P in millions of pre-orders for the phone as a function of the number D of days before the phone's release date. So looking back at this, before we even look at the question, we want to kind of break down what is going on in this equation. Okay, so we got this equation. We got P of D on the outside. That means that P is in millions, the number of pre-orders for a phone. D, which is inside the function, that's kind of like our X, is the number of days before the phone's release. Okay, so days is going to be my X value. My Y value is going to be the number of pre-orders. And remember, this is in millions. Okay, so now it says identify the transformations represented by the function as compared to the square root of D. Okay, so looking at this, we have a plus 20 on the outside. So what is that going to do to our function? We have a plus 20 on the outside. Not stretch. It is going to move it. Which direction though? Let me set it up 20. Okay. Now we got a negative chilling out front. What does that negative do to our equation? That 2 is going to stretch it. So stretch a 2. Stretch a 2. But that negative out front is going to reflect across the x-axis. The negative inside, and this one we haven't really seen much before, the negative on the inside of the radical is going to be a reflection across the y-axis. That's the new one. We didn't see that one last week. Let's go ahead and take a second. For domain, what does the domain represent? What do my x values represent? Days. And the y's, so my range, are going to represent what? The number of pre-orders, right? The number of phones that we're actually trying to sell. Okay, so for my domain, okay, we have to look at the number of days until the release date, right? Okay, so we know that 0 is going to be the end of those release dates. Like that's going to be the day that it releases, right? Now we're going to look at how far to the left does it go? So the number of days prior to that. But first we're going to look at the range to help us with that. Okay, let's think about this logically. The number of pre-orders. What's my highest Y value? What's my highest Y value? Look at the graph. 20. Okay. And then what's going to be my lowest Y value? Okay, so if you're selling something on the first day, let's say like nobody buys anything from you. How many things did you sell? 0. Okay, that's like worst case scenario, right? So it goes from 0 to 20 on my range. Okay, now our job is to figure out what day we started on. So how long this took us to sell that many pre-orders, right? So what we're going to do is we're going to take our equation and we're going to set it equal to 0 and we're going to solve. Okay, so I want you to take 0 equals -2, the square root of -d, plus 20. I want you to write that on your paper. So now what we're going to do is we're going to solve this equation. So we're going to first subtract 20. This is going to be real messy. Hold on 1 second. Let me clear this out really quick. I'm going to clear this and come back. So I'm going to take 0 equals -2, the square root of -d, plus 20. I'm going to subtract 20 from both sides. And then what am I going to do? I'm trying to get d by itself. So what do I need to get rid of? The -2. Okay, so we're going to divide by -2 on both sides. And that gets me 10 equals the square root of -d. But d still has a square root above it, right? So how do we get rid of that? How do we get rid of a square root? We square both sides. And so that's going to give me 100 equals -d. Well, what's connected to this d right here? The negative. So we're going to divide by -1 on both sides. So d is going to equal -100. So that means that it took from -100 to 0 for my domain. And for my range, we went from 0 to 20. Okay. On number 3, they ask us to determine the number of pre-orders the manufacturer can expect to have 30 days before the release date. So remember, D represents our number of days, right? So in order to figure out 30 days prior to the release date, what number are we going to plug in for D here? What number are we going to plug in here? Well, it wants us to find 30 days before the release date. Not negative 100, negative, it's going to be negative 30, right? So we're going to take our equation. We're going to go into Desmos. And we're going to plug in negative 30. Okay, so we've got 9.0. We're going to round that to 5. So we get 9.05. Come back in here. We get 9.05. Now remember, this is measured in millions. So that means that's 9.05 million. That's how many pre-orders they have sold 30 days before the release date. That makes sense? Okay, so on the first one, we told the transformations. On the second one, we said the domain and range. On the third one, we took this X value and plugged in, or D value, and plugged in. Okay, so go ahead and take out your computer. I know, Desmos is life, yo. Okay, so we're gonna watch it one more time. But after watching the video, what questions or wonderings do you have? Okay, so go ahead and type those in. A lot of y'all ask like stuff like, where is it going? What's the point of it? How fast is it going? That kind of stuff. So if I tell you this information, the Beaufort wind scale was devised to measure the wind speed. Beaufort numbers B, which is ranging from 0 to 12, can be modeled by this equation, where S is the speed in miles per hour of the wind. Okay, how would you use this information to solve the problem to find the wind speed? Okay, so on slide number 5, you can use that slide to show your work. But how would you use this information to solve the problem to find the wind speed? Okay, so how would you use this information to find the wind speed? Like, is this information even helpful? What will we be solving for? Bro, okay, you can go to slide 4 and y'all can see it. But let's talk about this video again. How fast, what would you describe this wind speed as? It's up pretty quickly, right? Okay, so like looking at slide number 4, which one of these numbers would that be associated with? Strong breeze? Probably like a 6 or 7. Okay, so devastation. I don't know about that. But okay, so we're saying 6 or 7. Where would we plug in that 6 or 7 into this equation? We plug it in for S. What's our other option? We plug it in for B, and then we could solve for S, right? We can figure out how fast the speed is actually going, right? Okay. Looking at act number 2. So they tell us what information? Here it is again. So they tell us it's a 7, right? Dang, y'all pretty good. Okay, so could you figure out what the wind speed is? Yeah, okay, go ahead and do that. I'll put it back up here. Okay, so we said it was going to be a 7. And then we're going to use this equation to find S. All right, let's talk. So if you set this equal to 7, watch what happens. You're going to add 3.49 to both sides. Thank you. And so that's going to give me 10.49 equals 1.69 square root of S plus 4.45. We're going to divide by 1.69 on both sides. And so that's going to give me 10.49 divided by 1.69. And then we're going to square both sides. We're going to square that number. And then we would subtract that 4.45. Okay. So how fast is the boat going? Miles per hour? What is it measured in? Miles per hour, right? Okay. So let's look at the last task. 34.1 is the approximate wind speed. So we were pretty close. Listen, just let me live my best life. Okay. All right, tomorrow we're going to continue on with some of this stuff. I know word problems give us a little bit of trouble. So tomorrow we'll pick this up.